Hi, everyone, this is the Encyclopedia channel. This program is about the order of time for you. This book will tell you some new achievements in quantum physics research. For example, in the microscopic quantum world, time does not exist. Will this subvert your understanding of time? So, what would a world without time look like? How can we still feel the passage of time? Is the me today, the me yesterday, and the me tomorrow the same person? After watching this video, you can understand why. The Earth appears to be flat, but is actually a sphere. The sky appears to be spinning, but we are actually spinning. Many truths that once seemed needless to be proved are just prejudices today. The same goes for time. Beginning with Einstein, physicists have repeatedly discovered that time is very different from what we perceive it to be, and in some sense it may not exist at all. The author of this book, Carlo Rovelli, is a famous Italian physicist, one of the pioneers of the theory of loop quantum gravity, and is regarded as an academic star in the field of theoretical physics. His other two popular science books on physics, 7 Lessons of Minimalist Physics and Reality is Not What You See, are very well received. So some people say that he is the next Stephen Hawking. Many theoretical physicists believe that the loop quantum gravity theory studied by Rovelli is a direction of contemporary physics research. Their goal is to solve one of the great puzzles of theoretical physics, explaining gravity in terms of quantum physics. It was in the process of solving the problem that they discovered that in the microscopic quantum world, time does not exist. Of course, this is a difficult problem for contemporary physicists to solve. Rovelli did not write this book to let you understand difficult physics knowledge. What he really wanted to say was that contemporary physics has shaken many concepts that are very basic and essential to us. For example, time, the basic law of the world that seems unquestionable to us, is actually just a variable artificially set. In this way, is it necessary for us to re-evaluate the way we understand the world? Next, let's share how to re-understand time from two aspects in the book. In the first part, how contemporary physics research, especially the circle theory studied by Rovelli, has subverted our concept of time. In the second part, let's talk about what the quantum world without time looks like. If there is no time, why can we feel the passage of time? First part. We are about to completely overturn our understanding of time. Let's think about a question together. Suppose we are good friends, I am by your side. If you want to know what I am doing now, it is very simple, just look at me. What if I'm in London, UK, and you're in New York, USA? Just a phone call away, right? But, is the me you see and hear the me right now? When you see me, you accept the light from me to your eyes, and it takes a while for the light to reach you, even if it's just a few nanoseconds. So, what you see is not what I am doing at this moment, but what I was doing a few nanoseconds ago. If you call me from New York and it takes a few milliseconds for my voice to reach you, what you hear is not my voice at this moment, but my voice a few milliseconds ago. This is not difficult to understand. Of course, you might say that we can't feel the difference of a few nanoseconds or a few milliseconds at all. What's the point of discussing this? So, what if I am on a distant planet, such as Proxima b? It will take 4 years just to get from me to you. Assuming you can see me with a telescope, you can only know what I was doing 4 years ago. The next question is, will I be at the same point in time as you are now after 4 years? Rovelli said, no. This is what Einstein's theory of relativity tells us. In the theory of relativity, time and space cannot be discussed separately. However, when we defined the concept of now, we did not consider the space factor, but only the time factor. So, in this sense, there is no common now in the whole universe. The effective range of the now we usually talk about depends on the precision we limit. If the precision is nanoseconds, now only exists within a few meters. If it uses milliseconds, the range of now is larger, thousands of kilometers. Rovelli said, now is like a rainbow touching the junction of the forest, you can see it, but when you walk through it, it's not there. Now is nothing but a vague feeling that human beings have based on their own experience. The same goes for time. In our consciousness, time is fluid and has a direction. However, contemporary physics has shown that these feelings may be wrong. In the past, we all thought that time was unified, and physics and astronomy both described phenomena in unified time, but this unified time was actually set by man. Einstein told us that there is no unified time, there are many, many times, and every point in spacetime has its own time. Humans have invented instruments that are more precise than traditional clocks to measure the gap in time, which can prove Einstein's point. If you put one instrument on top of the Himalayas and another at sea level in the Indian Ocean, you will find that time flows more slowly at sea level than it does up the Himalayas. Today, this conclusion is not only in theory, but also applied in real life. The time speed of GPS satellites is different from the time speed of the ground, because the small difference in time flow rate is taken into account. And this is just the beginning. Going deeper, you will find that time has no direction yet. Broken mirrors are hard to round, flooding is hard to get back, and what happened can't be reversed. These are our basic understandings of the world, but in the eyes of physicists, time is not like this. Time has a feature in physics called inversion invariance. Inversion is the reverse demonstration. Some physicists explain it like this: if you already know the current position and speed of a planet, you can use equations to calculate its future position and speed. However, you can also calculate backwards, calculating its position and velocity in the past, which is called inversion. Since both forward and reverse are possible, why do we say that one direction is the future and the other direction is the past? Rovelli said, "This is the secret about time revealed in the equations of physics. Time actually has no direction." So why do we think time has a direction? Physicists believe that the direction of time is related to heat. This is because in the equations of physics, there is an equation that cannot be reversed, which is the second law of thermodynamics. The core of this law is that heat can only be transferred from a high-temperature object to a low-temperature object, and not vice versa. For example, if you see a ball rolling in a video, you can't actually tell whether the video is playing normally or backwards, that is, the time in the video has no direction for you. However, if the ball stops, you can be sure that it is definitely not upside down, because you know that the ball will be subject to friction after it moves, so it will slow down to a standstill, and you will know the time direction of the ball, and at the same time we also know that friction generates heat. This shows that we perceive that time has a direction and is related to heat. You've probably heard that the variable that describes the change in heat is called entropy. Because of this relationship between time and heat change, physicists are guessing that the passage of time and the increase of entropy are probably the same thing, two different manifestations of the same thing. It was here that Rovelli set out to make his most subversive point, that time doesn't exist. Rovelli made a bold inference. We know that the increase of entropy is the process from order to disorder. Rovelli said, order and disorder are essentially subjective judgments of human beings, not objective phenomena, so there is no entropy increase in the universe, and there is no objectively existing time. This place is a bit difficult to understand, let's talk step by step. Let me first talk about why order and disorder are subjective judgments. Rovelli gives an example in the book. If you have 4 playing cards, the first 2 are red and the last 2 are black, you will think that these cards are in order. Then you shuffle the deck, the colors are shuffled, and the cards go from ordered to unordered. But notice that you think the change from ordered to disordered is because you are focusing on color. What if you care about numbers? Still, these 4 cards, they changed from 1246 to 6241. For you, the 2 sets of numbers have no special meaning, and shuffling just makes the cards change from one disorder to another disorder. Therefore, whether the change of shuffling is from order to disorder or from disorder to disorder is determined by your subjective choice. In fact, if you take into account all the variables of playing cards, color, number, and other factors, it's hard to say that any change is from order to disorder. The same goes for the universe. The universe is changing, just like shuffling cards, the variables in it are much more complicated than playing cards. We think that the universe is in the process of increasing entropy, from order to disorder, probably just because we choose certain variables to observe the universe. Of course, this point of view is difficult to prove experimentally. But Rovelli said that the results of the circle theory he studied can support this view. They found that if observed from the scale of quantum, the change of quantum is irregular, and these quanta just appear suddenly and disappear again. However, if we look at it on a human scale, the quantum changes appear to be orderly. We can understand it this way: the human scale is fuzzy, and many variables must be ignored, while the quantum scale is absolutely precise, and some variables will not be ignored, which is equivalent to taking all variables into account. This means that we observe order because we can only observe vaguely on the human scale and cannot observe all variables. Indeed, we can only see the universe in a vague way. At this time, you will feel that certain arrangements are orderly, and you will feel that the process of change is from order to disorder, and you will feel that there is an increase in entropy and time. So conversely, if we can achieve quantum-level precision, wouldn't entropy increase not exist? This is equivalent to saying that there is no objectively existing time in the universe. As we said earlier, now is just a vague feeling produced by human beings based on their own experience, and time itself is probably just a vague feeling produced by human beings based on their own experience. This conclusion is shocking, right? Is it true that such a clear, fundamental sense, the sense of the passage of time, is due to our inability to recognize the world in all its details? Although Rovelli's inference has not been fully confirmed by experiments, his explanation fundamentally shakes the way we understand time and the world. This is like when we discovered that the Earth is not static, but moving. But today everyone already knows that the Earth is moving, and the evidence is irrefutable. The second part. Speaking of which, you must be a little curious: what would a world without time look like? Why does the passage of time seem so real to us? In the second part, we will explain these two issues. Let's first go to the world without time with Rovelli. Rovelli said, the absence of time does not mean that everything is static. Time is gone, but there are still events, changes, and connections in the world. What he meant was that no matter what scale we look at, the only constant is that the world is changing. The opposite of change is stillness. In our general understanding, what is static is an object, and what is changing is an event. For example, a stone is a typical object, and a kiss is a typical event. We can say that this stone will still be on the Great Barren Mountain tomorrow, but you will not ask where this kiss will be tomorrow. These are two diametrically opposed ways of looking at the world. Historically, many philosophers and scientists have tried to understand the world from a static point of view. They regard the world as composed of objects. In Plato's work Timaeus, he described a static, precise, and perfect world in the book. We already know today that Plato got it wrong, largely because he chose the wrong direction and regarded the world as static. Rovelli said that the development of the whole science is telling us that understanding the world should be based on change, not static. The theories that reveal the truth, whether it is Newtonian mechanics or quantum mechanics, describe change, how events happen, not what objects are like. This is the way for today's physics to understand the world and approach the truth. The quantum world is a constantly changing world. When viewed from a quantum perspective, the world is no longer made of objects, but of events. Objects as we understand them are nothing more than longer-lived events in the quantum world. When you think about it, the hardest rock is actually changing. As we now know, stones are complex vibrations of quantum fields. It can also be seen as a momentary act of force, a momentary balance before shattering and returning to dust. This is the world that circle theory describes for us. The world is not a wall of objects, but a web of events, which cannot last, it is constantly transforming. Rovelli said that this may not be the best answer that has been recognized by the academic community, but it is the only consistent answer he knows so far. This truth is actually not difficult for us ordinary people to understand. A cloud is not an object, it is the condensation of water vapor in the air as the wind blows over a mountain. It is also a collection of events. What about us? People are not objects, they are complex processes of information, light, and language coming in and out, and they are a node in the network of social relations and emotional exchanges. A person is also a collection of events. So, if time is not a basic rule of the world, what is this thing we humans call time? What is my watch measuring? What is the feeling of always running forward and never going backward? Einstein once said a word in his later years. He said, anyone who believes in physics like me knows that the distinction between past, present and future is nothing but a persistent illusion. Many people quote this quote because they feel that Einstein was discussing the nature of time in physics. But Rovelli said that people actually misunderstood what Einstein meant. Einstein wrote this sentence to the sister of his good friend, because his good friend had just died. Before this sentence, Einstein also said a sentence, now he, Einstein's good friend, has left this strange world, one step ahead of me, but it's nothing. Then he said, anyone who believes in physics like me knows that the distinction between past, present, and future is but a persistent illusion. With the context, you will understand that Einstein did not actually refer to the time understood by physicists in this sentence. His feeling comes from the experience of life, which is fragile, short and full of illusions. Rovelli said, this passage talks about something deeper than physics itself. The idea behind Einstein is that time is created because of us. We can see the clouds in the sky, the teacup in front of us, and the cat sleeping in the sun. But if we go back to the quantum scale, there are no cats, no teacups, and no clouds in the world, all of which appear when we look at the world. It is also because of us that time emerges from a timeless world. Why do you say that? We just said that the flow of time is related to the increase of entropy. Entropy is actually a relative quantity, just like speed, there must be a frame of reference. When you say that a train is fast, you must have something slower in mind to compare it with. It may be another train or the platform of the railway station. The same goes for entropy. Entropy increase is not a state of the world itself, but a state relative to us. In our view, the entropy of the world in the distant past was very low, and the world was in the process of increasing entropy, so everything went from order to disorder, and there was a past and a future. It's just one way of describing the world, and we chose this particular way of describing it. Recalling the poker example just mentioned, this principle is not difficult to understand. The world we live in is probably only a subset of the universe. In this subset, we observe the special law of the color of playing cards, that is, the entropy is increasing, so we think that the entropy in the past was very low, so the second law of thermodynamics will hold true, so the world will have evolution, life, and thought. Finally, tell a fable to understand the deeper meaning of this conclusion. A king asked a wise man, Master, what is your name? The wise man said, King, I am called Nashien. At first it was just a name, a word, a title, a symbol, and there was no one here. The king was shocked, so he asked the wise man, if there is no one, then who is here wearing clothes and eating? He then asked, is the hair that first? Is that the first name? Does it feel like that first? None of these things, say the wise men. It seems that the king has won the debate, and if these components are not that, then it must be something else, which is the person in front of us as we generally understand it. But the wise man retorted, are the wheels a chariot? Is the axle a chariot? Is the chariot the sum of all these things? The king said, of course, the chariot is not only the whole of the wheels and axles, but also the relationship between them. That wins first. The name, then, is nothing but a collection of relationships and events. What, then, constitutes the unity of man? Why do I feel like the me today, the me yesterday, and the me tomorrow are the same person? Philosophers and psychologists tell us that there is a big reason why we have memories. What is memory? Memory is the combination of information scattered in time, and it is a way for the brain to process information. The latest neurobiological research has found that there are some basic structures in the brain, which record not the instantaneous phenomenon, but the process of movement. A ball appears in one place and appears in another place. The brain does not receive two different signals, but only one signal. It's like when you hear a note, your brain will combine the previous note with this note, and what you hear may be a melody. In other words, instead of taking pictures, the brain is taking small videos. Disney has a cartoon called Inside Out, which shows this mechanism very vividly. In this cartoon, the memory stored in your brain is piece by piece. Each piece is a beautiful glass ball. Touching it is like touching the play button of a small video. The memory is activated, and it is itself time is included. Regarding time, Rovelli's final conclusion is, time is not the basic law of the world, but what we human beings emerge from the world when we observe the world from a specific perspective in a specific subset. In the book, Rovelli repeatedly quoted the wise man's advice to Oedipus in Oedipus the King, stop investigating, otherwise, you will find yourself. In this questioning about time, we finally find ourselves. We have finished the book The Order of Time, so let's summarize it. Contemporary physicists have turned the notion of time upside down. Time has neither a uniform speed nor a direction. In the microscopic quantum world, it doesn't even exist. Time is not the basic law of the world, but a variable that appears when we humans observe the world from a specific perspective. Of course, Rovelli ignores many theoretical complexities in order to illustrate his point. Indeed, this book is not a rigorous physics work. Perhaps it should be regarded as a book that inspires us to think philosophically from the perspective of physics. It will inspire you to think about the nature of time and the way we understand the world. At the end of this book, Rovelli wrote such a passage: "I am not the body that is leaning on the sofa and typing the letter A on the computer at this moment, I am my own thoughts, of despair. I'm the one who made myself a cup of tea a minute ago, the one who just wrote this sentence I'm finishing. If it all goes away, am I still there? My life is made of this. We are the story, placed in the complex 20 centimeters behind the eyes, we are the line drawn by the traces of things mixed together, towards the direction of entropy increase, towards the future time." This is the end of this episode of the show. What do you think about it differently? Welcome to leave a message to discuss with everyone. Hey, if you like our channel, please subscribe us. Haha, remember to like it.